Okay, first I just want to apologize for you guys having a sub so much this week. If you know me at all, you know it's not something I like to do, but sometimes it's unavoidable. I am sick. It's not COVID if you're curious, but I am sick. I tried coming in Wednesday and it just didn't work out. I went home Wednesday before the day was even over. So we are going to do what we would normally do in class, the little warm-up videos or in-class notes, whatever you want to call it. So number one, it says put in standard form. First, when you look at this, you see x squared and y squared, and the leading coefficients are the same. They're both 1. So that's how you know this is a circle. It's positive x squared, positive y squared, matching coefficients. So this is going to be a circle. So we did circles in integrated 3. So you want to group your x together and add that empty box or place saver. Group your y's together. Add, I like to use a different shape because it's a different number. Move that 3 to the other side of the equal to. And to keep it balanced, you have to add the same square and the same triangle. Then I am completing the square. So you're welcome to draw the box, but it's always half of the middle term. Half of 4x, half of 4 is 2. That number squared, so this number squared is the box. 2 squared is 4. Both boxes are 4. See if you can do it for the y's. Half the middle term, half of negative 6 is minus 3. That number squared is 9 for the triangle. Combine like terms, add on the right-hand side, and it's 16. This is the standard form of a circle. You should be able to tell me the center and the radius. Tell me the center and the radius. It's in parentheses. Both of them are in parentheses, so it's opposite of both. And the radius is the square root of 16, which is 4. Remember, when they're videos, you need to pause them to catch up whenever necessary. Number 2, write the equation of a parabola in standard form that has a vertex at 5, 2 and a focus at 3, 2. My recommendation for this is that you always sketch what's happening here. So even sketch it to scale if necessary. We have 5, 2, 3, 2. It's all on the positive. It has a vertex at 5, 2. And then this is a vertex, a focus at 3, 2. What you should have learned from the video is that the focus is inside the parabola, so we know it is doing this. So when it goes sideways, well, first of all, you're not really used to the new form of a parabola equation. We put both of them in parentheses. And when it goes sideways, that means, so left, right, that means y is squared. Because you're used to regular parabolas where x is squared. That's an up-down parabola, right? And then specifically when it goes left, that means it's negative. The x's to the left are negative, so we know I'm going to have a negative in front of my parenthesis that is not squared. Y is going to be the parentheses that is squared. X is going to be the parentheses that is not squared. We know the vertex, so plug the vertex in the correct spots. The vertex was 5, 2. 5 for x becomes opposite, minus 5. 2 for y becomes opposite, minus 2. And then we know P. P is the distance between the vertex and the focus. In this case, it's 2. 4P is what goes in front of the parentheses. That's 8, and then we just said it's negative. You have to check for yourself to see if it should be positive or negative. I already had the negative sign there. This is the equation in our new, what's called standard form of that parabola. Pause the video if necessary. Find the standard form, find all the things. So completing the square again. When you look at this equation, x is the only thing squared, so that's how you know it's a parabola. X will be what we complete the square with. We should move everything else to the other side of the equal to bar, equal to sign. And keep it balanced by adding that same square. Half is plus 2, squared is 4. Add those together and you get 6. And then standard form, you need a single positive y, just like all those transformations we've been doing. This needs to be a single positive y, so we need to factor out -6. When you factor out -6, you get -1. This is our standard form, so that would be on the first answer blank. Then it wants vertex, focus, directrix, LR, line of symmetry, and a sketch. Fill in the vertex now. They're both in parentheses again, just like the circle, so it's opposite of both. We need to set up a sketch and help us find the rest of this. So our vertex is at -2, 1. X is squared. X is squared. That's up or down. 4p is negative, so that's going to be down. Set up some axes. Vertex at -2, 1. Then we know 4p is equal to 6 because it's the absolute value. We use the absolute value of 6. I know it's negative. That means it's going to go down. But for my equation, I just set it equal to the absolute value. So 3.2 or 1.5. So 1.5 down will be the focus. 1.5 down. So -2 is not changing. I'm going 1.5 below 1, so -0.5. 1.5 up, I ran out of space, but 1.5 up will be the directrix. Y equals 1.5 above 1, 2.5. Notice that it was x squared, so the x's did not change in any of my answers. The LR is how long it would be, and that's the absolute value of 4p, so that's just 6. Latus rectum, it's a length. The length of that is 6. So that means from across the focus, I have to split 6 evenly. So 3 to the left, 3 to the right. I split this to be a total of 6. Those are my other points I'm going to use. And I'm going to draw my downwards parabola. The line of symmetry is going to go straight through the focus and the vertex. That's x equals -2. Again, notice that it was x because this was an up and down parabola. So there's another example for you. It is the beginning of the chapter, so we will have time to do more of these together. Okay, the warm-up are the notes for section 9.2, ellipses. So first of all, I know that the video that you watched last night did not go over page 5. So we are going to go over page 5. Find that in your notes. And also, I understand this looks like an oval, but an oval is a 4-letter word in math. You never call this an oval. This is an ellipse. Ellipses have a lot of properties that ovals do not have, and we're going to talk about those properties on this page. So one thing you need to know, that our book calls co-vertex, or the co-vertices end points. Co-vertex is an end point. Whereas vertex is actually a vertex. And notice vertex is on the major axis. So I'm going to label or highlight the major axis orange. It's the axis that contains the vertices and the foci. And the length of the major axes is 2a. Because you go a to the right, a to the left, a plus a gives you 2a. The minor axis is where the co-vertex vertices are. I want that one to be blue. The minor axis is the shorter one. It has the co-vertex or co-vertices on it. It's perpendicular to the major. It has a center at HK, and the length of that is 2b. Excuse me. The foci are 2 fixed points on the major axes. They're the same distance from the center, and C is that distance from center. So the foci, just this distance, is C. And we're going to do some stuff with C down below in a second. Vertices are the endpoints of the major axes. Co-vertices are the endpoints of the minor axes. So here's what we need to know. I can tell this is an ellipse because two of the equations are squared. Sorry, two of the variables are squared, and it has a plus sign. This is an ellipse because two of the variables are squared, and it has a plus sign. For ellipses, the sign in the middle is plus. The sign in the middle of the C equation is minus. That's how I remember it. It's always opposite, because next class you're going to learn about hyperbolas, and they'll be switched. So C squared is always equal to A squared, where A is the bigger equation, bigger number. See how A is always the bigger number in that? Minus B squared, where B is always the smaller number. So it doesn't matter if B is under X or Y. What matters is that A is the bigger number in there. When A, let's just use purple. When A is always bigger, so A is always bigger. If A is under X, you're going to get a sideways stretched ellipse. Whereas if A is under Y, you're going to get a vertically stretched ellipse. So that was super important, especially the C equation, distance from the center to the foci. Our C equation always has a minus for ellipse because the ellipse has plus. So let's do some of these. Put the equation in standard form, find all the things. Okay, so completing the square again. Group your x's. Add a place saver. Group your y's. When I look at my y's, so first of all, x squared, y squared, plus coefficient of 1, coefficient of 4. That's what makes this an ellipse. Because it has a coefficient of 4, I am going to factor that out. I don't know, I'm going to use yellow. Factor it out of everything that has a y touching it. So it gets pulled out front. Divide by 4 and you get y squared. Divide by 4 and you get minus 2y plus a different place saver. Move that constant to the other side. Pause the video if I'm going too fast. Keep it balanced. I added a square and I added 4 triangles. Don't forget the coefficients. Okay, completing the square, half of it. Half of 6 is 3. Squared is 9. 9 for both squares. There's a coefficient. Completing the square, half of negative 2 is negative 1. Squared is 1 for the triangle. Negative 9 plus 4 equals 4. But standard form always equals 1. So you're not done until it equals 1. So to get it that way, divide by 4. Everybody gets divided by 4. Standard form. On this one, the 4's cross out. I'm going to put a y on the bottom, but a 1 on the bottom, but you don't have to. And now this is standard form of an ellipse. Center, vertices, foci, and a sketch. Sketching ellipses should be relatively easy. Find your center, write down what the center is. Opposite of both. That's my center. And then the number under each variable tells you how many to go left, right, up, down. So under x, excuse me, there's a 4. So just like for circles where you square root it, and you get 2. And I'm going to go 2. X is my left, right variable, so 2 left and right. 2 this way, 2 that way, because it's under x. Underneath, did I mess up the colors? No, I'm good. Okay, good. Underneath the y variable, it might be imaginary. You don't have to write it. Is a 1. Square root of 1 is 1. Y is your up-down variable. 1 up, 1 down. Try to make it look like an ellipse. We don't say oval in math class. Vertices are the points on the major axis, the longer axis. Since I've graphed it, I can literally just see what they are. 1, 2, 3, 4, 5. -5, comma 1, and -1, comma 1. Because the major axis was x, the y's are not changing. Foci, my C equation, c squared equals a squared minus b squared. Minus because ellipse has a plus, so the C has a minus. C squared equals, it's always big minus little. Remember, this is squared. That is a squared. This is b squared. So it's just 4 minus 1. C squared equals 3. C equals the square root of 3. Vertices and foci are on the same line. So the center was at -3. That means I'm going to go root 3 to the left, and there's going to be a foci, and root 3 to the right, and there's going to be a foci. So that means I'm going to go -3 plus or minus root 3, and the 1 value is not going to change. When the major axis is x, the y value does not change. My C value is what I add or subtract from the center. Okay. Number 2, find the equations. Set up a graph and sketch what's happening down there. Pause the video, go back if I go too fast. Whenever possible, go ahead and make it to scale. 0, 2 is a vertice. 6, 2 is the other vertice. Focus at 1, 2. Okay, we have the vertices. We have this distance. So the center has to be right in the middle. To find the center, you add and divide by 2. So 0 plus 6 divided by 2 is 3. Or you can just see it. If you make an actual accurate sketch, you can see the center. So equation of an ellipse. X something squared over something plus y something squared over something equals 1 to be an equation of an ellipse. I just found the center, plug the center in. Opposite, opposite. You can see A. This distance is 3. So if it went 3 to the left, 3 to the right, then this must have been a 9. Are we good with if you square root this from center, you'd go 3 to the right, 3 to the left. So that's why that's 9. Our C equation, we know A, and we can see this distance from center to focus, that's C, that's 2. So I can see that C, too many C's, is 2. 2 squared equals, we already know A squared minus B squared. So 4 equals 9 minus B squared. That came from the orange 9. Minus the 9, -5 is -b squared, so b squared must be +5. And remember, it's actually b squared that gets written under here. So this is 5, not the square root of 5. This equation would give us those vertices and foci. That's all we have for ellipses. Tonight you'll learn about hyperbolas. They're very, very similar. And then I will see you next week, and I hope you guys are doing well.